Same process, I'm not again explaining each and every step, but as I told, if x is equal to 0 is a regular singular point, and how we'll decide that, you all know the coefficient of y double dash becomes 0 by putting this. So we can say that this is our regular singular point, and if regular singular point, the trial solution is same as previous case. So this is our first step. Second step, substitute all these values in equation number 1. Then in third step, we just simplify. In fourth step, make power of x equal. In fifth step, make limit of sigma equal. In sixth step, we will collect like power of x. In seventh step, we will equating to 0 the smallest power of coefficient of smallest power of x, and which gives us quadratic equation in M, and which is known as initial equation. And by solving this, we have two roots m1 and m2, and nature of m1 and m2 decide this case number 3. So if root m1 m2 are distinct, like case number 1, and in case number 1 they are not differing by an integer, here they are differing by an integer. That means this m1 not equal to m2, but m1 minus m2 gives integer number. And here you have to just take less m1 less than m2. That means you have to give m1 for smaller root and m2 for larger root. Okay, so smaller root denoted by m1 and larger root denoted by m2. So when we have case 3, that in that case number 3 we have another two kind of logic. That means two cases. Case A. In case number 3 we have two case. Case A, when one of the coefficient of equation 2 becomes one of the coefficient of equation 2, that means equation 2 is our trial solution, and in trial solution we have coefficient that a0, a1, a2, a3. These are the coefficient in equation number 2. So one of this coefficient, one of any of this coefficient, okay, a4, a5, any of the coefficient becomes indeterminate for indeterminate. That means 0 by 0, okay, or infinity by infinity. If becomes 0 by 0 or infinity by infinity, for the smaller root m1, then this coefficient can be considered as arbitrary constant. That means you have to consider a2 as a2 only. No need to put the value of this, because this is indeterminate form, because its answer is 0 by 0. So we will not put the value of that m1. Just we will take a2 as it is in that y. If a3 becomes indeterminate, that 0 by 0, then a3 as it is. We will not put the value of m1. And hence the general solution is obtained by taking smaller root. Okay, m1 only taking smaller root only, by same to same case number 2, by same case 2. Okay, but we have to just put a2 as a2, a3 as a3 if we have a2 and a3 in indeterminate form, that means in 0 by 0 form. And in this case, no need to consider the larger root m2 if for smaller root this happened. And if this happened for the larger root, same process will be done by larger root, and no need to consider smaller root. Okay, vice versa. This is our case 3's first case. In third case, we have first logic. In second logic, in case 3, same m1 m2 are distinct and differ by integer, and we have to consider smaller root as m1 and m2 is larger root. In case B, when sum of the coefficient of equation 2, that means again same a2, a1, sorry, a0, a1, a2 and so on, becomes infinite for smaller root m1 only. For the smaller root m1, if any of this root becomes infinite, okay, infinite, then we will replace a0, this a0, by b0 into m minus m1. This m1 is our smaller root. Okay, we will replace this a0 by this in equation number 2. That means again same in trial solution. Okay, and we have the general solution is given by this. Same as I told, if you solve case number 2, you will understand better for the case number 3. Okay, but you have to remember this both condition. When if some of the roots become in indeterminate form, then we have to consider, we have to treat that coefficient as a constant, arbitrary constant, and we will use only smaller root. Okay, and no need to find for the larger root. If this be happen for the larger root, so we will consider only larger root and no need to consider smaller root, and we will same follow case number 2. That means we have just seen in B part, sum of the coefficient of equation 2 becomes infinite for the smaller root only. Here we will check only for smaller root. Infinite, then we will replace A0 by B0 into M minus M1. M1 is our smaller root. And we have the solution this. Okay. So let's understand one of these example. Which example I am not saying, that you will decide after watching this video. Okay, with this video continue. So let's start with the example. So we have this example: find the series solution of differential equation. This about x is equal to 0. So for x is equal to 0, the coefficient of y double dash becomes 0. So we can say that x is equal to 0 is regular singular point. And we know the trial solution is given by same as we know that this is our first step. Second step, substitute all this value in equation number 1. So this bracket as it is, we'll put y value of y double dash, x as it is, we'll put value of y dash, y as it is. Okay, so we have this. Now this as it is, y double dash, x as it is, y dash, and this is y. So now we will expand this, that means simplify. Okay, substitute, then third step is simplify. So x square into sigma, x into this entire sigma, x goes with here x, and this term as it is. So we have 1, 2, 3 and 4 term. So this is our simplification term. Okay, now I am not explaining because already I have explained 2 entire example. Okay, so x square multiply with this, so this become x raised to m plus n, and x multiply with this, so become x raised to m plus n minus 1. And this x multiply with this, so it becomes x raised to m plus n, and this x raised to m plus n as it is. Now we'll make power of x equal. So we have x raised to m plus n, x raised to m plus n, x raised to m plus n. Now to make this, we have to replace n by n plus 1. In which term? Second term. So n by n plus 1 in second term only. Okay, so all rest term, first term, third term and fourth term as it is. First term as it is, second term becomes this, and third and fourth as it is. Third and fourth as it is. Okay, third and fourth as it is. Only second term is changed here by replacing n with n plus 1 in this entire second term. So this sigma become n minus n is equal to minus 1. This n plus 1, n plus 1, n plus 1 minus 1 cancel out, this cancel out. Okay. So we have, yes, now we'll make limit of sigma equal. So we have 0, 0 and 0 is larger than this, n is equal to minus 1. So we'll put minus 1 in this and we'll start with n is equal to 0. So we have this term first as it is, second term just I will write down again, and we'll put n is equal to minus 1 in this. So we have first term as it is, this first term as it is, and second term gives us this step. By putting n is equal to minus 1, we have this, and we'll start n is equal to 0. This is as it is, and this as it is. Okay, so we have this step is our limit of sigma equal. Now then we'll collect. So we have only one term with x raised to m minus 1, and all the terms are with x raised to m plus n. So we'll take together all these 4 terms. So we have this is our collect step, step number 6. Now we have step number 7, equating the 0, the coefficient of smallest power of x, and smallest power of x is this. Okay, so coefficient is, we have this is our coefficient. Now as we know that this a0 will never be 0, so we have m into m minus 1 is equal to 0, which is our initial equation. By solving this, we have m is equal to 0 and m is equal to 1, as we decided that smaller root always denoted by m1 and larger root denoted by m2 in each and every case. This by default you have to just decide. Now here you can see that m1 and m2 both are distinct but differing by an integer. You can see these both are different, but difference is minus 1 and minus 1 is integer. Okay, so it is case number 3. Now in case number 3, A or B, which part is applied here, that will also decide after getting recurrence relation. Okay, so after deciding this, that's by equating to 0 the coefficient of various power of x. So we have these entire that sigma. Okay, so Here a0, an plus 1, a0, sorry, an. So an take together, and we'll take this on the right hand side. So we have this an plus 1 in this, an outside. So we'll make this subject. So this goes to denominator. Okay. And now, as we have decided this, if we take common this from this two term, m plus n minus 1, this is minus 2, n plus 1 as it is. Now, same we can make a factor, multiply with this, multiply with 2. So we have this term, and as I told, if we consider this x, so x square minus 2x plus 1, denominator as it is. So x square minus 2x plus 1, that means x minus 1 whole square, and we decided x as m plus n, so m plus n minus 1 whole square. Here no term is cancelled out, but we have to simplify so we can find easily the value of these coefficients. Okay, so here we start n is equal to 0 because we have last in collecting step we have sigma is starting from n is equal to 0. Okay, this is our recurrence relation. Now we will start to put n is equal to 0. So we have this by putting n is equal to 0, n is equal to 1. Okay, so we'll put value of a1 from here. So we have this our, by simplifying this our a2 and so on. Okay, so we'll put all this in equation number 2, that means in trial solution. Okay, this is our trial solution. We'll put a0 as it is. We'll put a1 and a2. So we have this equation number 3. Now we'll start with the smaller root. Okay, because this is case number 3. We have smaller root is m1 is equal to 0. If we put m1 is equal to 0, you can see that this is our a1. Okay, this is our a1. If we put m1 is equal to 0 in this, so this is 0, that means something upon 0, that because this is 0, this is 0, minus 1 is to 1 is 1. 1 by 0 is infinite, so a1 becomes infinite. If a1 becomes infinite, so because of this a1 we have this a2, so it is also infinite and so on. So hence all this becomes infinite, and this is infinite, that means this is our part B. And as we told, if sum of or anyone is becomes infinite for the smaller root, then we will replace a0 by b0 plus b0 into m minus m1. m1 is our 0, so we will replace b0 m in equation number 3. That means in this trial solution, after getting this equation, here we will replace this a0 and a0 with b0 m, because b0 m into m minus b0 into m minus m1. m1 is our 0. Okay, so we will replace here in this 3 place. So we have this entire equation number 3 we will replace here. So this is b0m, a0 become b0m, a0 become b0m, and all the rest terms are as it is. Now we can take b0 common, we can cancel out this m, can cancel out this m. Because of that m, this becomes infinite. So now it's not, no more this is infinite term. Okay, so we have this y is our final answer. This is our final answer. And now we will use this smaller root to find first solution and second solution, as we told. Okay, that's same as case number 2. Okay, so first solution, put m1 is equal to 0. This is our equation number 4, final y. Okay, we will put m1 is equal to 0. So we have y1 x is 0, b0 and 0 plus this is 0, this is 1, so x, this is 0, and so on. So rest of all terms become 0. So we have only b0x. This is our first solution. Now for second solution, we have to differentiate this y. Now we have this is big y that we have to differentiate with respect to m. Consider this x is constant because partial derivative. Okay, so we have second solution. I'm just taking in the next slide. So we have second solution, differentiating equation 4 with respect to m. Okay, so this is our equation number. This is our differentiation. How we find this differentiation? So this bracket as it is, and differentiation of x s to m is x s to m log x, and this x s to m as it is, and differentiation of this bracket is this one, that you have to differentiate by yourself. Okay, and I'm just giving you hint here to differentiate this, and all the rest term are neglecting because this becomes 0 after putting value. So how I just differentiate this in this form? So for that, consider y is equal to m minus 1 whole square. I'm just giving you shortcut method. We have this y, and now we want to differentiate this with respect to m. Okay, right? we want to differentiate this with respect to y. So for that, I have just taken log on the both sides. So log y is equal to log of this is log y, this minus log this. And in log, we can take two common, two in forward. So 2 log m minus 1 minus log m plus 1. Okay, now we will differentiate this with respect to m partially. So we have 1 by y, del y by del m is equal to 2 m minus 1 is the differentiation of this, and minus differentiation of this m plus 1. So we have del y by del m is equal to y into bracket this 2 upon m minus 1 and 1 upon m plus 1. Now what is the value of y? So we have y is m minus 1 whole square upon m plus 1. This is our y. Now we just decided for this. Okay, not that original y. We just suppose y. Instead of y, we can suppose z also. So we will suppose z. 1 by z, 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 z. So what is the value of z? This. And now if we multiply this inside this term, okay, so you will get this bracket, this bracket. You can see that by cancel out this, we have 2 m minus 1 upon m plus 1. Yes, and if you multiply here, so m minus 1 whole square upon m plus 1 whole square. Okay, so how you differentiate this? Simple, or you can use division method also. Division method, okay, u by v rule also. Okay, so we have two method. You can use either of this. So this is our del y by del m, and we will put m1 is equal to 0 in this. So we have y2 is equal to v0, x raised to 0 is 1, so log x, and we know that this will give us x because we already find in first solution. Now this becomes 0, so x raised to 0 become 1, so we have v0 and 1, and this gives us minus 3, so minus 3x. Now we can take v0 common, so we have x log x plus 1 minus 3. This is our second solution. After first solution and second solution, we have same concept, the general solution y is equal to c1 y1 plus c2 y2. So this is our solution. We will consider this capital A, this is our capital B. This is our general solution. Okay, and we can say that A is this and B is this. Similarly, we have this example for your DIYs, and keep practicing. We will see you soon with next lecture. Thank you very much. Okay, and again, I'm just telling, please practice more examples so you can understand better. Thank you very much.